It is my very great pleasure to introduce your first two speakers. If you would, please welcome from eTrack, Mike Mueller, and from Autodesk, Pete Kelsey. Guys, come on up and talk a little bit about some of the real interesting stuff that you guys have been doing. You guys are going to find the stories you hear today, you're going to find them fascinating and touching and informative and more and more and more. So guys, over to you.
Thanks, Jonathan. I'm Pete Kelsey. I've got a great job in that I get to seek out and then engage on interesting projects that push a number of different boundaries. The USS Arizona project being one of them, that we've been talking about, I don't know, maybe a little over a year now. But this is great for me because for the first time, got one of the team members up here with me. If Mike, you want to say hello.
I'm Mike Mueller. I'm actually a founder and run a hydrography company locally here in the San Francisco Bay Area, and met up with Pete, brought us into this interesting project. We use a lot of Sonar, and that was coupled with other technologies Pete was already using on the project, and it was fun to come into the project a little bit later in the game, but to see it now through the finish almost.
Right, right. So Mike was one of the project members, and very happy that Dennis Hirota here on the couch is also here. To a short version of who did what. Dennis was key with the LiDAR. Mike and his team were key with the Sonar. So I'll take you through a little bit about it, but in terms of sort of the real story, what Mike and I have really been wanting to talk about is, one of the greatest things Mike said is, this wasn't easy. This is, what did you say? This is one of the hardest?
So there were parts of it that were fairly difficult compared to some of the other work that we've done.
So let's get into it, show you a little bit about it. So first, just a bit of history. So the Arizona was built in Brooklyn, early 1900s, launched in 1917, obviously proud ship, about a crew of about 1,100, refitted a few times because it entered service so early. A lot of modernizations were happening along the way. And then, of course, that day in December 1941, when the attack came, the Arizona, of course, was there and suffered the largest loss of life in the entire attack. Specifically, a high-altitude bomb from 10,000 feet, if you can imagine this, hit between turret 1 and turret 2 in the bow of the ship and lit off the forward magazine, which set off just an incredible explosion. 1 million pounds of ammunition blew off at once. So we fully expected to see some pretty serious damage when we got to the sonar portion in the stern, which you'll see here in just a second. The ship sank in 9 minutes, burned for 3 days. I mean, it was just incredible fire, inferno. And basically, anybody in the forward section of the ship did not survive and are still in the ship. And for guys like Mike and I, whose honor it has been to dive on the ship, it's a moving place and a really important place to do this kind of work, this kind of research. So I forget the actual amount of time, but sometime in the 50s, believe it or not, thanks to one Elvis Aaron Presley, the memorial was funded and actually got built. And here's what it looks like today. And this is actually, to me, one of the most sort of contextual images, right? Because you can see the ship, whereas if you've been to the memorial, and you look out over the side, on a good day, you can see some stuff, but a lot of times you can't, and you don't really get context. But this, there's a 600-foot battleship straddled by this memorial. And of course, steel battleship in salt water for over 70 years. Odds are it's not the same ship today that it even was a year ago. Whoops, wrong direction. So, the impetus for this project was the Park Service wanting to establish a baseline data set to use for change detection going forward. Steel battleship, salt water, our cracks expanding, our decks sagging, what's going on here, because this is hallowed ground. It's a war grave. There's 900 guys still in the ship. So the last time they looked at the ship was in the 80s, 30 years ago, and the result is what you see here, which, cutting to the, having seen the sonar data and actually been in the water, this is remarkable, remarkably accurate, but took 3 years to produce, all done by hand, and it's 2D, okay? Well, what we set out to do, we did this. This is literally Mike's work. This is the composite, just a look at the composite sonar imagery of the Arizona, specifically turret 1 there where the guns still remain. Okay, project team, extensive team, and I never talk about this project without, expressing my thanks over and over again to these people, because everybody you see here on this list donated their time and their expertise and their hardware and their sweat pro bono. They just wanted to be part of this project, and Mike and Dennis included. And we took, collectively the risk was kind of off the charts. We hoped this was going to work, but frankly there were a few things that we weren't sure about, and that's kind of the real story of the Arizona. But what we strive to do, or what we did, I guess was a series of firsts, was combining these different kinds of reality capture software for the first time. And one of the things, I shouldn't speak for you, but one of the things that interested Mike and his guys was photogrammetry, yeah?
Yeah. So from this list, our firm has done, in a production sense, a lot of these things individually, separately on projects. But to couple them all in one and to bring them together into a georeference point cloud for this
monitor.
For this reason, for a different, it's not a production environment, it was very unique to us. And one thing we hadn't used before was subsea LiDAR, and we had never even thought that undersea photogrammetry was being done. And so Pete changed our mind on that. And what our role in this was, we were brought in about halfway through to provide input to georeference the separate point clouds that were created, separate surfaces. And that was really fun for us. We got to take individual components, pull them together, and watch the puzzle start to take shape in 3D this time.
Right. So quickly about the LiDAR, so another tip of the hat to Dennis's guys. So, standard terrestrial point cloud of the memorial itself, but I don't think I mentioned this, oh, by the way, no one had looked at the memorial since its construction. What's going on there in terms of change detection? Is it going to fall down? Is it going to fall over? The Park Service was keen to understand that dynamic as well. So that's just, the first component. There is a terrestrial component to this as well. And Mike can speak to the sonar.
So for the sonar component, we used 2 platforms. One of them was this small vessel in the upper left, a 17-foot boat that was there for us, run by the National Park Service. So we flew all of our equipment in and mounted it up on a specialized sonar mount. You can see it sort of protruding off the side of the boat there, making it list. And we also coupled that with a very shallow water a USV, similar to the one you can see out here, but much smaller. And so operating multi-beam sonar, there are a few $100,000 worth of sonar equipment on this little gadget that needs to drive underneath and lose GPS coverage. Keeping all that data georeferenced properly, that was a real challenge for us. It's something we had never really tackled before. And then once we were done collecting with these 2 entities, this is an example of what the multi-beam sonar does. It's very similar to LiDAR, as you see it, mobile LiDAR, just with sound instead of light. So it was remarkable to see, as you're painting the seafloor from these different components, to stitch it all together. And here's a little video of the craft going underneath the memorial. This is filmed from above the memorial. Maybe TJ even filmed this. You can actually see some of the oil, the bunker oil that's still in there, bubbling up, which still comes from the
But one of the challenges, right, Mike, was that it was so shallow, right?
Yeah. The water depth was 15 centimeters, and we were running aground with the vessel at times and going out, swimming out to get it at times, or pulling it out from in the water. So
right.
Right. Yeah, it was very different from what we normally do for bigger boats. You want to talk to?
Sure. So the other thing that this is almost a year ago where we brought 3D at depth out, is I wasn't aware that there was subsea LiDAR, but there is. And what was great about this particular vendor, Mark and his guys, were that, that our piece of gear weighs 250 pounds. It's tethered. That's the blue optical cable there you can see on the deck of the ship. So his words, right? We're not mobile. I'm not so sure about shallow water, but we've got to try this because the demand for shallow water work, which Mike echoed, is on the rise. So that worked. Here's a quick look at some of the data, the results. Huge footprint, right? Because the tripod that this 250-pound thing sits on is big. And just get your head around, how do you move 250 pounds worth of stuff underwater? Float bags and about 8 divers. I mean, it was intense. But the data was spectacular. I mean, you could speak to this. I get asked a lot, what's the difference between the subsea LiDAR data and, say, typical sonar data? Is it fidelity? What do you think?
Yeah, we can see it in the next videos.
Yeah. And then the last component, of course, is photogrammetry, which another guy here in the room was proud to be a part of a team. We got interested in would 123D Catch at the time work in underwater photos, and took what we learned, brought that as another component to the ship, and it worked, and it really worked well. So this is a cooking pot in the area of the galley on the deck of the ship in about 6 feet of water. Dive team took a bunch of pictures swimming around it, modeled it, and then generated a 3D print of it in color. This is to scale. I think this is 1/3, right, Sean? 1/3, which I'll come back to in a minute. But this print was to play a pretty key role for a lot of us on the team as time went by. So here's a look at kind of where we are to date. So this is recap, where we brought in all of Mike's sonar and looking at the ship. Now you'll note some data gaps, and maybe Mike, you want to speak to that. So why am I about to see some big black holes in the data?
Well, we had some problems with the first remote-controlled craft. We worked out some kinks, and so we sent another one out. And just last week, we finished by filling all those gaps in. It took yet another trip out there to get that, but finally that's been completed.
Yeah,
so we're happy about that.
Yeah, but the challenge I think you mentioned was when that USV goes under the memorial, you lose satellite. So the challenges were, wow, thank God Mike was with us. And then bringing in all the data types, the LiDAR and the sonar together in InfraWorks to give it that context. Wow, okay, I can tell that's a battleship, but you bring it here, and you throw in a diver to, try to give it some scale, and wow, I can tell where I am, and I can splash, I can go underwater, which is sort of changing the conversation now with the owner, with the Park Service, who's now saying, we could virtualize the park. We could, make it available online, if you will, for all the people who can't physically come to Pearl Harbor and can't get in the water, because, divers aren't allowed in the water. You have to have all kinds of permission. So it's one of the sort of many results of sort of kicking this hornet's nest that's been, exceptionally positive for all of us. One of the dive team, I'm not going to steal Sly's thunder because you're about to meet Sly Lee, who was part of the Arizona dive team under contract to the Park Service, and basically said, I got an idea. I'm going to run with this coral thing. And his work has been stellar, which you're about to see. Another Park Service diver said, I know where there's an old F4U courseware in about 100 feet of water. I want to go have a look at it. This, if you're a diver, this was done with 10 minutes of bottom time. 10 minutes, as it's at over 100 feet. So it was swim, shoot, swim, shoot, swim, shoot, and get up. And to date, other than what you're about to see from Sly, this is probably the most spectacular maritime photogrammetry model I'm aware of yet. But if you guys have something, I definitely want to see it, and I know Mike does too. And then finally, this last component, which I didn't come up with, but boy, I've been parroting it a lot, which is this idea of going from the physical to the digital back to the physical, meaning so let me back up. This gentleman you're looking at here, this is Don Stratton, 93 years old, and was on the ship during the attack in the bow, and he survived. Terribly burned, year in the hospital, really interesting guy, and great to spend time with. But this is an image of, you see my laptop there, and I did what techno guys like I do. Don, let me show you the data, you're gonna love it, it's really cool. And he was, I think that's my ship. But when we put this pot in his hand, there were 25 people in this room, Don started to well up, I welled up, and then the other 20, there wasn't a dry eye in the place because this guy my ship, I get it. I have no idea what you've been talking about for the last 45 minutes, but this, I understand. And, we couldn't put Don in the water. We couldn't pull the pot off the ship. So this was a great alternative to sort of share that experience with him, okay? So more to come, but thanks very much. And Don wanted to thank everybody as well.
Thanks, Mike. Thank you. Thanks, Pete.